All right, we're going to look at Lithophanes today. This would be a lithophane, unlit lithophane right now, so it's just kind of a block of brown plastic. We're also before we do that though, at our blaster and where we're at with it. So I've done a few more things, not a lot. I've basically painted a few things black. Well, I did the adhesion promoter, then primer, then I painted them black. And I used a black spray gloss paint. I don't even remember what brand it was. It was not a particularly special brand. It was just black gloss paint. And this piece, so the frame for the grip, I sanded on it a little bit. In fact, you can kind of see some of the sand marks, but it generally, you can see some layer lines. I didn't spend a whole lot of time. Let's see if I can find what I used to sand it. Mainly I used this, just a little sanding stick. And when you're sanding something that is going to have a flat surface like this, not curved or undulating or anything, then you want something relatively rigid to sand with. It doesn't have to be completely rigid. It can comply a little bit, but you want some kind of sanding block. Now this particular piece is pretty narrow, so it doesn't make that big a difference, but what happens if you had a large flat surface or a large surface that was supposed to be smooth and not all these dips and hills and valleys in it, and you don't use a sanding block of some kind and you just sand with your hand, then you're probably going to get your hand shape in the surface. And a lot of people make the mistake of they just sand, back and forth. If you do this while you're sanding, then you're going to have little bumps where your fingers were pressing on the sandpaper. Even if you're pressing pretty lightly, you're going to get that. So you want to use some kind of sanding block that's going to maintain that flat surface if you're trying to produce a flat surface. Now, if you're trying to produce a flat surface on something like this, curved, then you still want some kind of sanding block, but you go across it at an angle across the surface and then back the other way. You don't really go down. You don't really go across it this way. You're trying to go across when you're sanding at an angle across that curve, and then you go back the other way. You don't do circles. You don't do straight lines. Well, I guess straight if they're angled like this. Hopefully you know the difference between what I'm trying to say there. But a sanding block will help you a lot if you're trying to create something with a smooth surface. Now, I didn't spend a whole lot of time. In fact, you can even see some of the sand marks in here. This is pretty coarse. One side is, I don't know, maybe 100 grit, and the other side might be in the 200 grit range. It doesn't actually tell me what they are, but this is smoother than this side. And that's not super important. You generally do want to start with a rougher grit though, so that you knock out the really high spots. Like this was printed, right? So it was printed probably laying like this, and it had the elephant's foot on those first few layers where they stick out a little bit. And so it had a little rim around the edge here. And so you use the really coarse side first to knock down that stuff quickly. You don't really actually want to start with fine grit, like 1,000 grit or anything like that. I usually want to start with something in the 100 grit range, 120, 80, whatever you have. I mean, there's some standard grits, but something in that range, somewhere around 100 grit. Basically, the 100 is telling you how many, I think it's how many pieces of grit or whatever it is, aluminum oxide or whatever is embedded in your sandpaper per square inch, I believe. And so if you only had 100 of those grains per square inch, that is a coarser texture than something that has 1,000 grains per square inch. So I did two different things here. Well, the only difference is this one I sanded some, and this one I just painted it off of the printer. So, well, I did the adhesion promoter primer on both of them, sanded this one some, didn't sand this one, just let it dry, and then sprayed them both at the same time with the black gloss. And you can see, like this guy, you can clearly see the layer lines and everything. It does not really look like a printed, oh, well, no, it does look like a printed one. It doesn't look like a piece of metal. You it loses the illusion when you've got all this lines in here. Now this is the back side of this one. I haven't even done the front side yet. So I probably will come back and primer and sand on this side. But I just wanted you to see the difference in doing nothing. This does have primer on it, but no sanding or anything. And here, you know, if you look, you can still see the layer lines, but they're actually kind of hard to see even with the gloss paint. Now we're going to go over this in a second, and then we're going to flat coat it, which will probably remove them all together. You won't notice any layer lines, but I'm okay with that on something like this because I would think that this thing would be machined out of a piece of metal, and it would probably have some machining marks on it. And I'm okay with there being some amount of little layer lines if you see them, because those I could pass off as machining marks. And the scratches, I'm totally okay with scratches on this because we're making a worn, weathered looking one. So scratches are just going to add to the fact that it's been beat up. So the idea here is that this would be the frame, you know, and this would have bolted to it. We'll probably just glue it together and put some kind of fake screw head in that hole, and then we got to do the other side too. We haven't done that at all. Well, I did primer it, so it is that far, and I did sand it a little bit. Although I don't know if you can see in there, but there's still some layer lines showing in here that I don't think I want in this one. They're a little bit rough, although it is wooden, so could be wood grain, but I don't know. What I wanted to show you with this is, let's get all this out of the way, a different technique. So the last time on this guy, when we wanted it to look metal, we used the rub and buff, which I think I still have over here. Yeah, we used this. And we could probably use this on here. I don't know how that would turn out. I think it would overpower it and be too much silver. So we're going to use a paintbrush. And I don't even know if I need this, but we'll get it out. Actually, we'll put this down. We can use a paintbrush and some silver paint, and we're just going to get a tiny bit on here. We don't want a whole lot, and then we're going to wipe most of it off so there's just a little bit. And then if you kind of just drag this across the surface, you'll get these little scratches, and all the raised corners where things would get bumped or whatever are going to pick up more of that paint. Now I think I need a little bit more. I don't have much on there. This paint's kind of dried out, so I need to get a little more on there. And it is called dry brushing, so I don't want a soupy paint, and I don't want a lot of it on here. I just want some so that it'll kind of pick up across it. And if you kind of randomly go across it, you'll get those little light scratches. There's a blob I don't want. But the corners will pick up more of the paint. And now I've got, I'll put this on here, it shows up better. You know, you've kind of got a little edge there that looks worn compared to the other side that we haven't done anything to. So here would be the pristine side. Here's the worn side. It looks a lot more worn. And once we put our flat coat on here, because I don't want this too shiny, we'll put a dull coat, the same one that we put on, the mini guys, the ogre or orc or whatever, and dwarf thing we put on them. It's just a little spray that's, instead of making it shiny, makes it kind of dull. I think this will look really good. And so that, I don't think, would go in and really make this any better though. I don't know if I've got any paint left. Might have to get a little more paint. We could try it though, just to see. This is the back, so I'm not terribly worried about it. And I'm not actually trying to make one of these. I'm just using it as an example. So if we end up with one that's good, if we don't, it doesn't actually matter. Let's just kind of randomly go over it. And on this one, you don't want a super nice brush because you're going to kind of beat it up. So it can totally be a cheapy one. Now the problem might be that if your layer lines are really prominent, you might end up picking up the layer lines. And you can be kind of rough, assuming you don't care about the brush. Let's see. It helps a little bit, but it's so the layer lines are so prominent. Well, these aren't layer lines. This is the top layer. It was printed flat. They're so prominent that I think you would really need to do some kind of sanding on this primer, or maybe a higher build primer, or maybe more coats of primer. If you just spray straight on top of it with no sanding, it really still looks 3D printed. I mean, it looks nice, but still looks 3D printed. Maybe you could use a really heavy dry brush to hide some of that, but I don't know. I think it doesn't. It helps, but it's not good enough. Maybe if we use some of the rub and buff on there. In fact, let's try it. See what happens. The only thing that could happen really bad is that we had to. Now, it's going to be tough to paint over, or I don't even know if you can paint over this because it's basically wax. So once we put this on there, we're probably stuck with this piece the way it is, or we print a new one. So let's see. Now this one is, remember, this stuff is so, it spreads so easily. I don't want a lot of it, but maybe we can get a tiny bit on there and see what it'll do. And again, it doesn't matter a whole lot if you mess up on these, because you're trying to make something that looks worn and worn out. You can actually use your finger to smear this stuff in. Yeah, the problem is when you still have all of that deep surface, it gets hung up in that surface, and it's just not going to look as good if you don't sand the primer. So it's not ruined. We'll come back, and actually this part goes up against, well, it goes this way, up against the thing, so nobody's ever going to see that anyway, because we're going to glue it on there, or maybe we'll screw it on, I don't know. Probably just glue it on. And this is the side that anybody sees, and here, so we need to sand in there. All right, so enough of that. What we were really doing today is, and this is a relatively short topic, not a long one today, is these Lithophanes. So these things came around actually in the 1800s or so, and they were made out of porcelain. So somebody would carve a piece of wax and use that to create a mold, and then they would pour porcelain in there and fire it and make it really thin porcelain, and it'd be thin enough, and porcelain is a little bit translucent anyway, that light could shine through it. So this is mimicking that effect with a 3D printer. Now, FDM printers can do this. It takes a long time, and they aren't great at it, not like maybe a resin printer would be. But this particular one, I had a little bit of issue. Had some peel right here. You can kind of see it's not flat like it should be. Sure. It peels up over in that corner. These things, you could print them laying down flat, right? You're not going to get the amount of resolution you want for it to really work that well. You have to print them, or it's better to print them standing up like this, or like this, whichever way your printer is oriented. I'll show you on the printer in a second the best way. But the idea is that you get a filament. Now this is brown. Normally you're using something like a cream off-white color. That works a little bit better. It's not transparent though, so it's not a see-through filament, but you print it thin enough that you can shine some light through it, and you get a picture. So instead of just a block of kind of looks like carved chocolate or something, you actually have a picture when light shines through it. Now I'm having to use a really bright light kind of at a point, so it's washing out a lot of the details. But if you hold it up to something like regular light, not something, a flashlight, then it actually looks like a picture that's popping out of this thing. So a couple of things about making these. First of all, there are plenty of online resources. I used, let's find the one that I used. I used this. It's litho.com, tools.itslitho.com. And basically you upload a picture. So I found this picture of a 65 Mustang. I like those. If you saw the previous video where we did the photogrammetry, then that was This is not my Mustang. Mine looks like this if it were clean, but you saw the state of it not at all being clean. And we scanned this front corner of it with the pictures and the photogrammetry. But this is a nice one that someone's taken a picture of. And all I did is uploaded the picture. And I did change the contrast. The contrast came in like this, so it was a little bit dull. And I figured that I would get a little bit better results with the lithophane if I bumped up the contrast a little bit. So I did to somewhere in there. I don't remember what I actually used. But just to get a little bit darker colors. And the idea is that when you print the dark colors and and it's going to be black. You can actually do these in color. I have not tried a color one, but let's assume you're doing more or less a black and white one or a brown and tan one or whatever. Is the darker colors are going to be thicker so that more light from the backside will not pass through, and the brighter the color, the thinner the print will be. And so you can kind of see, let's see if I can get it at an angle where you can pick up what's going on there. I don't know, maybe you can see in here where the window has a dark shadow across it, and the shadow underneath the car is dark, obviously. Those are all raised up compared to all of this other stuff. The car is white, so most of the car body is really thin compared to everything else. And so you're blocking different amounts of light. I don't know if it'll focus that close. Kind of, yeah. You're blocking different amounts of light. There you can see how this part's sticking out right here. And the shadow's sticking out. The tires are sticking out. So you're blocking more light where the parts are darker, and it doesn't show through to what you're looking at on the side you're looking at. So back to here. You can do that. You can go to Photoshop and create this yourself with some kind of height map based on the color, of the grayscale color of the picture and all that kind of stuff. This picture was originally not a grayscale picture. It was a color picture originally. But this piece of software, and I assume most of them like this, convert it to grayscale. So I did that. You can rotate and crop and all this kind of stuff, edit it over here. I didn't do any of those things other than I did change the contrast a little more to get a little bit more difference between the bright colors and the dark colors. And then you go to the model, and it will take and figure out what it needs to print. So here's the model, 3D model of what it's going to print. There are some of these that create them as globes, as curved surfaces, as this kind of picture frame type thing. This one will let you do map it to these different options. So if we could map it to a pumpkin, I didn't do that one, so I don't know what it's gonna look like. It says it's, oh, there we go. Oh, it really did put it on a pumpkin. So I'm not sure why. I guess somebody just wanted to figure out if they could do that. I would not recommend the pumpkin one. The sphere might be cool if you were doing a lithophane of like the moon or something, but let's just go with plain. And I took all of these as default settings, I believe. So the width and the height, that's just how big do you want the thing. You don't want these very big because they take an extremely long amount of time to print if they're in the proper orientation. So this one took, the one that we did here, 3.5 hours, I believe, to print is how long it took. And it's a relatively small one. It's not even that big. So the larger you make these, then it's going to take a while to print. And we should have printed this one at a smaller layer height, which would have taken even longer. Let's see, you could adjust the minimum thickness, so the light color, what is their minimum thickness? You could have adjusted that. I didn't. I left it as, you probably do want it as an increment of your nozzle width. So we have a 0.4 millimeter nozzle, so 0.8 means that we'll at least have 2 layers everywhere in the model. 2 walls everywhere in the model, because we're going to print this standing up. The maximum thickness, that just kind of controls, both of those together control the range of colors you can have between the dark and the brighter color. You could build a frame around it if you wanted to. These are all default. I didn't change any of those. This one you might want to change, minimum millimeters per pixel. I did not test this out, but you could probably set this to your layer height and it would help a little bit. So you want these to be printed at a thinner layer, maybe 0.12. Oh wow, that's going to take a while. Let's get down to there. On the Ender 3 anyway, that's probably a good layer height. 0.2 or maybe even 0.16. All of these numbers, if you notice, I haven't talked about this. We sort of hinted at it when we talked about stepper motors and micro stepping, not baby stepping, but the micro stepping, like the half stepping, quarter stepping, 16th stepping, and so forth. So if you remember about that, you could take full steps. There were 200 full steps in a stepper motor, the kind that we're using, or you could take half steps. So those are in between the full steps. So you could take quarter steps, which were in between the half steps, and so forth, down to like, we changed that board out so we could go down to like super tiny steps. What happens is the smaller the step is, your motor torque changes because it's having to sit between steps instead of sitting always at a full step. It's having to divide some of the current between different coils unevenly, or maybe evenly, but it's still having to divide them. And so you can possibly, on really sensitive prints like this one could be, you could possibly see differences when your motor lands on a full step and prints a layer, and then it steps over a tiny amount, a micro step of some amount, and prints another layer. There could be a little bit of difference in the that motor torque holding that layer steady as it prints the micro step versus the full step layer. All of that to say that each printer has what are called magic steps, and these are the ones where, depending on the geometry and the mechanism of your printer, so the stepper motor controlling the z-axis and the screw that's attached to that z-axis, it has threads on it, and depending on that, each printer will do better at certain increments. And so for the Ender 3, if you haven't changed anything as far as that screw and the stepper motor that it's attached to that move the z-axis up and down, then that increment is 0.04 millimeters, 0.04 millimeters. And so if you do any increments of 0.4 millimeters, then you're going to be using what's called the magic steps. Now, most of the time it's not going to make any difference. I didn't actually use it. I think I printed this at 0.15, so that's not one of the magic steps for the Ender 3, but I didn't print it on the Ender 3. I printed it on a different printer. You would do better to do everything you can to get nice even layers. So you've checked your E-steps, you're extruding just the right amount. You're printing relatively slowly because you need a lot of detail here. And you're using the magic steps, which for the Ender 3 would be a layer height of 0.1 if you haven't changed out your nozzle. So you're still at the 0.4 millimeter nozzle. 0.1 is about as thin as you can go. Then 0.1, then you could go to 0.12, and then you could go to 0.16 and 0.2 and so forth, layer height. So those would be reasonable layer heights. And we could look up magic, make sure magic layer height for Ender 3. Yeah, there they are, 0.16, 0.12 in there. I guess it didn't. Here we go. Well, I thought it would just tell us, but made bed temperature. Oh, these are all nice settings for, there we go. There they are, 0.6, 0.12, 0.08. So I guess actually 0.1 isn't a great one, but it's about as thin as you can go for other reasons. I don't know, I haven't tried. I don't know that you could get an Ender 3 to go to 0.08 millimeters with the 0.4 millimeter nozzle. That would be tough, I believe, for it to do. So maybe 0.12 is the minimum for a 0.4 millimeter nozzle. 0.1 I know it can do, but it apparently doesn't land at one of the magic layer heights. Now these aren't actual magic. It doesn't mean that your prints are magically going to start coming out much nicer, but it gives them a better chance of coming out much nicer. So if we did this, 0.12, oh, there's other things you can do down here in attributes. You can enable a stand behind it so that it actually, it's going to have to create it. It'll snap on to like a night light or something. It'll snap on to a, or it has a spot for a, I'm going to have to turn the night light off for it to do that though. Little LED, like a little candle LED type thing or something to go behind it and just always light it up or whatever. So you can, I didn't enable either of those. The model options, that doesn't, there's no real reason that you could change the color here in the preview. Basically the image options, maybe you need a negative image. You don't really want that. It would invert all your colors and it would look backwards. You could mirror it. Then maybe you want to do that, mirror or flip it. But you also had a chance to do that kind of thing in the upload. So once you get that, then there's just this big download button and it sends you a STL file. And then you end up with something like this. So we're over in Cura now. Now this one I've already sliced. It takes a while to slice. And let's show you how it's sitting on the bed. So here's your printer. Here's the front left corner where it homes at normally for the Ender 3. And this is how you would want to print it in this orientation. Let's go to the prepare. You would not want to do this mainly because the bed in the Ender 3 is moving back and forth. And if you set this thing in the same direction that the bed is trying to move, the top, by the time it gets to the top, is going to start wobbling back and forth versus setting it aligned with that where it's not going to really wobble and it doesn't move left to right. You know, to do the left and right motion, the print head itself moves left and right. The bed only moves forwards and backwards. So this is the best orientation. You might be tempted to do this, and this would work and it would be much faster, but you're not going to get as much detail out. You know, it's not going to go in and have as many transitions between the different thicknesses. Basically every layer height is all you get. So if you're going to do it this way, it'll be faster, but you definitely want to use the thinnest possible layer you can. And you might even get stringing between some of these, like over here, printing this layer, when it goes from here over to here, you might get strings in between there and you got to clean it all up. Maybe if you just want to crank out a really quick lithophane that's not going to look that great, you lay it down flat like this and print it. It won't take as nearly, let's see what layer height. We're at 0.1. Let's do the 0.12 like it said was one of the magic ones. Well, let's say we tried the 08. We got it really tuned in and we can do the 08. So let's slice it and see what it looks like. I did not print one like this. And I figured that it would have a lot of trouble. First of all, you'd have to deal with warping. This big flat box on the plate would be really tempting for it to warp. So I'd add a brim probably so I could tape the brim down as it prints and if it tried to lift. Even this is taking a while to slice, although we're at a really thin layer. Notice I've put top layers as 500. Basically, I want it to be solid. I don't want infill. Because I don't want to see the infill pattern shining through. So I want it to be a solid thing. So I just set top layers to something I knew was bigger than, so everything would be a top layer. You could also set the infill to 100%. I think in most cases that would generally do the same thing for a lithophane. But this is a little trick you can do if you need a part to be stronger or a little bit more detail, is instead of making it 100% solid with infill, because infill has its own printing speed over here. You know, infill speed has a different printing speed from wall speed and top and bottom speed. Now it'll slow things down, but make it all top layers, and that will make it solid, and it will take more of a finished, you know, layer every layer. So you wouldn't want to do something very large this way, but and this is still going. I thought it was almost done, but it's kind of stopped on us here. I wanted to see what this would look like, at least in the preview. There we go. 9.5 hours. Now we're at a really thin layer height, 0.08. But let's look at the preview of it. If it doesn't kill the computer. So, this one probably would be okay, assuming your printer could actually handle the 0.08 layer height, which I don't know if it would do well with that or not. And it's got some weird, I don't know what that is. There's some weird moving in there. I didn't slice that correctly. It would probably be okay, but that's not what I would recommend to do. What I would recommend is turning it up on its edge. Now I only added a brim, and the 0.08 in this orientation would take, let's do 0.12. So, and I think at 0.12 we're gonna have, let's make this 1,000. Now you definitely want to change this. I do like that Cura comes in and highlights these in some orange color or whatever, and when you've changed them from their default numbers or something that's way out of what normal, so that you kind of remember to change them back. I dropped it down to printing at 40 millimeters a second. You might even drop slower than that, depending on how well your printer's rigid, how it doesn't shake and vibrate and all that kind of stuff. You probably at least want a brim, and you might want to print this on a raft because it doesn't have a lot of area holding it down, right? There's only this thin little rectangle that holds it down, and this whole bed's going to be moving back and forth. So you probably want a brim, maybe even a raft to hold it down. Let's slice it and see what we're looking at. I printed it at 0.15, I believe, so a little bit thicker. This one would turn out a little bit better. Let's see how long it would take. 8 hours. So I printed it at 0.15 on a different printer, so a printer where the bed moves up and down and you don't have to worry about the bed moving back and forth, so you can go a little bit faster. And it took 3.5 hours. Now it told me it was going to take 2.5 hours, but it took 3.5 hours. When you're doing everything as top layers, the estimates are usually way under what it actually takes. So don't be surprised if this 8-hour print took 9 hours to print or whatever. Let's look at the preview of it and see what it's going to look like. And there's the brim, holding it down, giving it some more area to actually have a chance to stick down. And it doesn't look like much at all, and there are some parts that are just poking out there that you have to wonder if they're going to survive or not. But they did all survive on the one I printed. But here's kind of what you want. You don't want an infill pattern in here. You want it to be all solid. However you get it to be all solid, it would probably be fine to change it to just 100% infill. But I just wanted everything to be as consistent as possible, so I did it all as top layers. Because like in here where it's kind of thicker, if you didn't have enough walls, now I think I have a lot of walls on here, maybe 4 walls, 3 walls on here. So it would probably just be all walls, actually. But if you had some infill fill in here that wasn't the same as everything else, then you would end up seeing that pattern in your lithophane, which you don't want to see. That's kind of what it would look like. So they're pretty cool. You do want to make sure you've done all the other calibration first, like you've got your E-steps, like we talked about last time, set in. You want to avoid the lifting here like I had, where you have a corner that comes up. It doesn't mess up the lithophane, but now it's kind of not attractive. It's got this lift to this corner. You can probably see it there. And filament that's not transparent itself, you do want some of the light to be blocked. Otherwise, it's not going to give you the effect if it all just passes through. It won't give as good of effect. But I mean, even this one looks pretty good. In person, it looks a little bit better than what the camera's picking up. But I think this particular printer had a little bit of over extrusion issues because it's a little bit lumpier than it should be. But it is a really tiny print also. It's not very big compared to some of these other lithophanes. Just be ready that if you're going to do this, it does take quite a while to print one of these. So, in the multiple hours to print one of these. Like I said, this one was 1.5 millimeter layer height, and it took 3.5 hours on a printer that runs pretty fast compared to the Ender 3. So this on the Ender 3, you know, you're looking, well, this was 0.12 layer height, and we were at 8 hours already. So they're fun, they're interesting to try and work with, but they're time consuming, and you probably want to make sure everything's tuned before you set off into making one. I suppose you could try one, you know, 0.2. 0.2 is not going to give you a good one, but it would give you the idea of how well your printer is going to handle this in general without it taking forever to do. Still 5 hours to do it at 0.2 millimeters. 0.3 millimeters, I don't even know if you'd want to really try that. I don't think that would come out very well. It might be okay. You could always print one laying down flat with the thinner layers and a little bit faster. 3 hours, but I think you'd lose most of your resolution on your picture. It might still look okay and do the lithophane idea of having light block and pass through in other locations, but it wouldn't give you the details. The one that I did here isn't even the best ones I've seen. I've seen much better ones. Some of it has to do with the color filament. Again, if you have a beige or a cream color filament, that will work better than something darker like this. This one does kind of work, and it makes it sort of a sepia kind of color palette, but they generally are better if they're kind of a off-white color. Okay, and I think that's all I wanted to talk about today. We talked about our blaster and what we're doing with making it look a little worn. Next time we'll do some more of that. Wanted to show you what a lithophane was and how to go about doing one of the best ways to set it up. The main thing is set it on its edge. A lot of people are tempted to lay it down flat, but if you want a really nice one, set it on its edge and use a layer height that is probably relatively small and just wait for it to print. But since you're going to be waiting a long time, make sure you do something to stick it down. So a brim or a raft to make sure it really sticks down, because on its edge it's going to have a really tiny area of contact between the bed and the thing. So some tips: print it all top layers a little bit slower than normal, and align it so that, well, let's just make sure you know exactly what I mean. So let's go to the printer here and let me move it out of the way. So here on the printer. So if you're on the printer, this thing is going to be printed this way. So I don't think it'll stand up that way. So that when the bed is moving back and forth, it's not vibrating as much. If you put it this way and you move back and forth, it's going to vibrate the taller it gets. So align it with the direction that the bed is moving, like this, and you'll have a better chance of it coming out well. And again, if you lay it down flat, it'll work, but it's not going to work as well as the standing it on its edge. You just won't have the resolution. You get more resolution moving the print head around to create all these ins and outs of the thick parts and the thin parts of the layer, versus here where all you can do to create the difference between height is move the head up a layer and print a new one, and move it up point whatever millimeters and do it again. So this is the better orientation, like this, on this printer that moves the bed back and forth. All right. Also, you shouldn't move your bed back and forth very fast, because you are driving the stepper motor back here. And when you do that, the stepper motor acts like a generator and does send electricity in back to the system. So if you do that a lot, if you actually move this bed back and forth a lot by hand, you will power up some of your system opposite of what it's normally powered up. And you can, I've never actually burned anything out that way, but I think it could be possible, unless there's some protection circuitry in there to stop that from happening. So don't just, if you need to move things, it's okay to move them. Just don't move them really fast when you're moving them, so that you're not generating any back power into your system. All right, let's come back on Wednesday. I don't know what we'll talk about. We're about done with the course. I think I'll keep doing some of these. Just maybe we probably won't finish the blaster during this time of the course, so maybe every now and then I'll come back and update on what it's doing. But we've covered a lot of the stuff to get you started with 3D printing, particularly FDM 3D printing. We did just a handful of resin printing things. Maybe I'll drag out the resin printer after we're done with the official course part and do some more with it. It's just so much messier to deal with, but it's interesting. It can print some really nice detail. All right, we will see you on Wednesday, and that probably will be the last one, I think, maybe one of the last one or two in this series, and then we'll start up something new. All right, see you Wednesday.